I am Raghavan, chemistry faculty from All Force College. Welcomes you for All Force chemistry e-learning classes. Okay, in this session 14th. So now today we are going to discuss about some numerical importance of Bohr's theory, okay, and hydrogen spectrum. In the last session we were discussing about some concepts of Bohr's theory only, that means radius numericals and energy numericals. Now today also let us concentrate more numericals on the same concept. Okay, so now let us write the numerical part. Okay, the radius of first orbit of hydrogen, that is radius of the first orbit of hydrogen means the radius of Bohr's orbit of hydrogen. That is, Bohr's orbit means it is nothing but first orbit of hydrogen. Okay, the radius of first orbit of hydrogen atom, first numerical, the radius of first orbit of hydrogen atom, first orbit of hydrogen, the radius of first orbit of hydrogen is 0.53 angstroms, is given as 0.53 angstroms. Okay, and calculate the radius of third Bohr's orbit of hydrogen atom. Calculate the radius of third Bohr's orbit. That means calculate radius of third orbit. Okay, he has given the radius of the first orbit of hydrogen as this much, 0.53 angstroms, and he is asking us to calculate the radius of the third orbit. Okay, what is the basic fundamental for this? The radius of nth orbit is equals to radius of the first orbit into n square by z. That is a basic fundamental to calculate radius of nth orbit of species containing one electron. So now using this, so now radius of third orbit is equals to radius of the first orbit. It is given as 0.53 angstroms. 0.53 angstroms into n square. He is asking us to calculate radius in third orbit, that is 3 square, that is equals to 0.53 angstroms into 3 3s are 9, that is equals to, so that answer is 0.53 into 9, so 4.77 angstroms. The radius of third orbit of hydrogen atom is 4.77 angstroms. Okay, so this is the answer. Like this we have to calculate. So once again, the given question is the radius of hydrogen, the radius of Bohr's orbit of hydrogen atom means first orbit of hydrogen atom is 0.53 angstroms, and now calculate the radius of third orbit of hydrogen. That is the question. Okay, now the logical approach, the radius of nth orbit is equals to radius of the first orbit into n square by atomic number, that is the species containing one electron. This is applicable to the species containing one electron. Okay, for hydrogen, okay, z is equals to 1 only. Radius of third orbit is equals to radius of the first orbit into n square. Okay, done. So that is 3 square means 9. So 0.53 angstroms into 9. So it comes 4.77. Okay, this is one numerical, right? So like this we can calculate radius of the nth orbit of species containing one electron. Okay, that is Bohr's theory is applicable to the species which contains only one electron. Okay, next problem, let us see the next problem. According to Bohr's theory, okay, let us see. According to Bohr's theory, the angular momentum of the electron mvr is equals to nh by 2 pi. Okay, that means mvr is equals to nh by 2 pi. What is the angular momentum value in fifth orbit? Okay, that is the question. Let us remove this. Okay, let us write the question. I will write the question here only. Okay, the question is angular momentum of the electron mvr is equals to nh by 2 pi. Okay, this is the representation of angular momentum of the electron in the circular orbit. Okay, circular, that is Bohr's orbit. Now, what is the angular momentum of the electron? What is the angular momentum of the electron in fifth orbit of hydrogen atom? In fifth orbit, that's all. So, angular momentum of the electron in fifth orbit. Angular momentum of electron in fifth orbit. In fifth orbit. Yes, that is equals to, in fifth orbit is equals to, that means n is equals to 5. That means, that is 5h by 2 pi. That means 2 ones are 2.5. Okay, so therefore that is equals to 2.5h by pi. The angular momentum of the electron in the fifth orbit of hydrogen is represented as 2.5h by pi. Okay, like that. So like that questions we can expect. See, this type of numericals are frequently repeated in competitive examinations. So this was in EAMCET and it was in even mains also. The concept is very important. So what is the data available in this? What is the question he is asking exactly? So, and the question is raised based on angular momentum. So angular momentum, always you have to remember that. So that is angular momentum of the electron revolving in the circular orbit is always equal to the integral multiple of h by 2 pi. Okay, where n is equals to integer, that is orbit. Okay, now what he is asking, so what is the angular momentum of the electron in fifth orbit? That means n is equals to 5. So 5h by 2 pi. So that is 2.5h by pi. So that is the concept of the second problem. Okay, we took. Next, let us see another concept, that is yes, let us say the concept is the radius of which of the following orbit is same as that of first orbit of hydrogen. Okay, let us pick out the problem like this. The radius of which of the following, the radius of which of the following is same as that of first orbit of hydrogen atom. Okay, is same as that of radius of first orbit of hydrogen. Okay, first orbit of hydrogen atom. Okay, so what are the options? What we can consider? Let us consider the first option as helium ion radius. Say n is equals to 2. That means the radius of helium ion, second orbit radius. The radius of second orbit of helium ion, is it equal to the first orbit radius of the first orbit of hydrogen atom? That we have to, let us take. This is first option, let us say. Second option, lithium 2 plus second orbit. That means the second orbit of the radius of second orbit of lithium, is it equal to the first orbit of hydrogen? And third option we can make out lithium plus 2, n is equals to, say n is equals to 1. That means the first orbit of lithium ion, is it equal to the radius of the first orbit of hydrogen? That is one option we can make out. And let us say fourth orbit, beryllium plus 3, n is equals to 2. That means the radius of second orbit of beryllium, is it equal to the radius of the first orbit of hydrogen atom? So 4 options we have prepared. Okay, so based on this now we have to work out. So once again the question is the radius of which of the following is same as that of radius of first orbit of hydrogen. Okay, radius of first orbit of hydrogen. What is the radius of first orbit of hydrogen atom? So we can say radius of first orbit of hydrogen, let us consider as 0.529 angstroms, or you can say 0.53 angstroms. Let us say it is R1. Okay, so radius of first orbit of hydrogen, radius of first orbit of hydrogen atom. Okay, say it is, that is 0.53 angstroms, or let us say it is R1. Okay, let us say it is R1. Okay, right. Now, which of the following is equal to that? Okay, first let us take the first option. What he said, the radius of second orbit is equal to the helium ion. That means radius of second orbit of helium plus. So what is the relation we can explain? So radius of nth orbit is equals to radius of first orbit into n square by z. This is the relation we have to follow for species containing one electron. Okay, now that is R1 into n square, that is second orbit. So that is 2 square by atomic number of helium is 2. So that is equals to R1 into 2 square, that is 4 by 2. So it is twice. So it is twice that of hydrogen. It is not equal. So that is why the first option is not our answer. Okay. And second option, what he says, so that is lithium plus 2. That is second orbit of lithium plus 2. The radius of second orbit of lithium plus 2. Is it equal to the radius of the first orbit of hydrogen? We have to verify that. Okay, same concept we have to follow. So that means radius of second orbit. Okay, second orbit of lithium plus 2. That is equals to radius of first orbit of hydrogen into second orbit, that is 4, 2 square by 4. That is, now lithium atomic number is 3. Z is equals to 3. So this is not equal to radius of the first orbit of hydrogen. Okay, so the second option is also not correct. It is not equal to the radius of first orbit of hydrogen atom. Okay, now we are taking the next third option. What is the third option says? Yes, the radius of first orbit of hydrogen, is it equal to the radius of first orbit of lithium? Is it equal to the radius of first orbit of hydrogen? Let us check. So third one, radius of first orbit of lithium plus 2 equal to, so that is why R1 into first orbit, that is 1 square by lithium atomic number 3. So this is R1 by 3. So it is not equal again. So that means this is not our answer. Okay, first 3 options are gone. Now coming to the fourth option is, so what is the meaning of this? The radius of second orbit of beryllium ion, is it equal to the radius of the first orbit? Let us see. Radius of beryllium, that is second orbit of beryllium. Radius of second orbit of beryllium plus 2 plus 3 ion is equal to the radius of the first orbit of hydrogen into n square, that is n is 2, that is 4. 2 square means 4 by atomic number of beryllium is 4. Yes, 4 cancelled. Yes, that is equal to R1 of hydrogen. That means the radius of the second orbit of beryllium plus 3 ion is equal to the radius of first orbit of hydrogen atom. Therefore, our fourth option is right. Okay, so we have 4 questions are there. This is one question, this is one question, and this is one question, and this is one question. 4 separate questions are there, and only one question is linked with this 4. That is, the radius of which of the following, is equal to is same as that of the radius of first orbit of hydrogen atom. So out of the 4, so the radius of second orbit of beryllium plus 3 is equal to the radius of first orbit of hydrogen. That we found as correct. Okay, so that is the numerical concept, right? The next numerical, let us see. Yes. Let us prepare the same question on the same concept. So the concept is the radius of the first orbit of hydrogen atom, say it is r. The radius of first orbit of hydrogen. The radius of first orbit of hydrogen. First orbit of hydrogen atom is, say, r. Okay, say r. The radius of first orbit of hydrogen atom is r. The radius of the first orbit of lithium will be, the radius of first orbit of lithium will be, the radius of first orbit of lithium 2 plus will be, okay, let us take options like number 1, first option is say it is r by 9, second option is 3r, third option let us make out r by 3, and fourth option is 9r. okay, make it 9r. So according to the general concept, we can use the same logical approach, that is radius of nth orbit is equals to the radius of first orbit of hydrogen into n square by z. That is a logical approach we have to follow. So now, so that is radius of the first orbit of hydrogen atom is r. Okay, r. Now the radius of the first orbit of lithium, that is n is equals to 1. Okay, it is first orbit of lithium. Lithium atomic number is 3. So therefore it should be r by 3. Third option, r by 3. It cannot be r by 9, it cannot be 3r, it is r by 3. The radius of the first orbit of hydrogen atom is r. This he said r. What is the radius of first orbit of lithium plus 2? So that is first orbit means orbit is 1. So therefore n1, that is n square is 1 square by lithium atomic number is 3. So it is r by 3. Okay. So like that we can expect numericals for the objective examinations, because the theoretical concept you can understand. So once the concept is understood properly, then you need a lot of practice on that. We have to work out the different types of numericals. Okay, so by doing repeated practice, so the application skills will develop. Okay, so that application skills only the student needs, because they have to apply when see the question in the examination. Okay, so that is, if the question is understood, but the application of the concept, I have knowledge but I am unable to apply them, so that is useless. So that is why the student has to vigorously work on the bits to develop their application talent, application knowledge. That is very, very important. Okay, once the student, it totally depends on the hard work of the student. Okay, so up to 10th class the standard of student may be different. Okay, they may be a below average, or they may be an intelligent student. So in intermediate first year, that is in 10 plus 1, 10 plus 2 category level, so it completely depends on the hard working nature of the student. Okay, if the student is hard working, it has hard working nature, and they can develop the skills, application skills, and they will flourish in the objective examinations. Okay, that is thing, right? Next, let us see the next problem is, okay, Yes, let us prepare the numerical like this. Calculate the wavelength of H alpha line. Calculate the wavelength of H alpha line in bracket series of hydrogen spectrum. Calculate wavelength of the H alpha line in the bracket series. Calculate, let us write. Calculate wavelength of H alpha spectral line in bracket series. In bracket series of hydrogen atomic spectra. Yes. Okay, done. So let us say R value, Rydberg's constant value, R value is equals to 109,678 centimeter inverse. Okay, R value, let us take like that. Okay, what is the question? What is the problem we make? So calculate wavelength of the H alpha spectral line. Okay, so I wrote in short H alpha spectral line in bracket series. H alpha spectral line in bracket series of hydrogen spectra. Okay, I repeat the question. Calculate wavelength of H alpha line, means H alpha spectral line in the bracket series of hydrogen atomic spectra. So the Rydberg constant value is provided. Okay, now the formula we can use. Wavelength we have to calculate 1 by lambda, that is equals to, so let us proceed with the beginning. Nu bar is equals to 1 by lambda, that is equals to R. Okay, RH. So it is bracket series, that is bracket series H alpha line. Okay, first orbit, second orbit, third orbit, fourth orbit, fifth orbit, sixth orbit. Okay, it is n is equals to 1, 2, 3, 4, 5, 6 orbits we took. Okay, when higher energy excited electron, when jumps from higher energy levels to first orbit, when electron is jumping to the first orbit from anywhere from higher orbits. So when electron jumping to the first orbit, that gives Lyman series. In first orbit it gives Lyman series. So it is Lyman series. Now we don't consider, we consider only bracket series. Okay, when excited electron jumping from higher energy level to second energy level, the spectral line is visible in that is in the visible region, it seems, and the series is called Balmer series. Okay, that is also not considered for us now. Balmer series not considered, both are not considered. Next, when excited electron jumping into the third orbit, so that spectral line is visible in near infrared region, that is called Paschen series. That is also not required for us now. When excited electron is jumping into the fourth orbit, the spectral line of the corresponding emission radiation appears in middle infrared region. The spectral series is called bracket series. Yes, for bracket series, the N1 is equals to, that is, it is forming at fourth orbit. So therefore, N1 is equals to fourth orbit. So that is 1 by 4 square minus. So it is H alpha they mentioned. H alpha means what? The first line in the series. In that series first line, that means the electron is dropping from very next higher energy level. That is fifth to fourth. The electron is dropping from very next higher energy level. So it is dropping to fourth orbit. Means the higher energy than fourth orbit is very next higher energy. That is fifth orbit. So fifth to fourth. So electron is coming from higher energy. N2 is 5 and N1 is 4. The electron is coming from fifth orbit, that is N2. Okay, that is fifth orbit, 5 square. Okay, here we should remember that is N1 is equals to 4 and whereas N2 is equals to 5. That is for H alpha spectral line in Balmer's, that is in bracket series. So we notice it from this, we understand from this. Okay, then we can solve this. So that is 1 by lambda is equals to R. How much it is? 109,678. That is centimeter inverse. This is centimeter inverse. into 1 by 16 minus 1 by 25. So solving this, you will get the answer, that is, so how much answer we can get? That is 1 by 4, that is 4 square, that is 16, and it is 25. Right, it is 2467.33, yes, 33, or make it 73, that is centimeter inverse. Centimeter inverse. So this much, that is, this is nothing but 1 by lambda, nu bar only. Nu bar we are getting this much of value. Okay. So now, as we know that nu bar is equals to 1 by lambda. Okay. Now lambda is equals to 1 by nu bar. 1 by nu bar, that is equals to 1 by 2467.73, that is equals to how much we'll get? So that answer will be 0.00040 centimeters. Okay, it is centimeters, or make it 4.0 into 10 to the power 1, 2, 3, 4, 10 to the power minus 4 centimeters. That is wavelength. Okay. Calculate wavelength of H alpha spectral line in the bracket series of hydrogen atomic spectra. Okay. So we calculate it like this. Okay. So first we should remember the basic fundamental, that is nu bar is equals to 1 by lambda is equals to RH into 1 by N1 square, that is ground state of the bracket series. Okay. Next minus 1 by N2 square, that is excited level as per the question, higher. Okay, excited level as per the question. So that is the formula. Okay. Now what he is saying, H alpha line in bracket series, H alpha line in the bracket series. So bracket series is formed at 4th orbit. That first point we should understand. So Lyman series is formed at 1st orbit, bracket series, Balmer series in 2nd orbit, and Paschen series is formed at 3rd orbit, and bracket series is formed at 4th orbit. Okay. So since bracket series is forming at 4th orbit, we can say N1, that means ground state, ground level of that series. Ground state of that series, that bracket series. So that is N1 is equals to 4. Okay. It is formed at 4th energy level. Okay, done. So N1 is equals to 4 square. So from where the electron is coming? The electron is coming from, that is, it is alpha. Alpha means what? So if the electron is coming from 5th to 4th, 6th to 4th also electron comes. And even the electron may come from 7th to 4th. And even the electron may come from 8th to 4 also. Okay, it may come 8th to 4. It may come from 8th to 4th orbit. Okay, like this. Okay, now these spectral lines we have. So, sir, first line, what is that first line? So, the electron is dropped from the very next higher energy level to that ground state. Very next higher energy level to that ground state. That is 5th orbit to 4th orbit. That is called first line. Okay. Instead of H alpha, sometimes you may also find the question first line or second line or third line, or instead of that H alpha, H beta, H gamma, H delta. Okay. These are the terminology of the spectral lines. Okay. Let us make it. So this is H alpha. H alpha. This is H beta. And this is H gamma. And this is H delta. So these are the various spectral lines. Okay, in the bracket series only we are discussing about it. So this is first line, and it is second line, and this is third line, and this is fourth line. Okay, so this is about terminology of the various spectral lines. H alpha says, H alpha means the electron is coming from 5th to 4th orbit. So therefore it is 1 by 4 square minus 1 by 5 square. Done. It is 1 by 4 square means it is 16. It is 1 by 5 square means it is 25. Okay. So now on solving this, we will get, that is nu bar is equals to, 2467.73 centimeter inverse. Okay. So as we know, this is nu bar. Now what we have to calculate? Calculate wavelength, he said. So nu bar is equals to 1 by lambda. Lambda is equals to 1 by nu bar. So now lambda is equals to 1 by nu bar. That is equals to 1 by, yes, this is wave number we substituted. This, on solving this one, we get the answer 0.00040 centimeters. So that is equal to this. Okay. Right, like this we can solve the numericals based on hydrogen spectra, that is hydrogen spectra, and we have done some numericals based on Bohr's radius also we have done. Okay, and yes, we can also prepare the numericals like yeah.